How about representing this instruction, LW? So we have in LW instruction, we have source register, destination register, one source register and a destination register, and instead of having a second register, we have an immediate value 52. So just assume that you are a part of a company and you're designing our own processor. So what do you think? How will you cope up with this instruction? We have to keep the instruction format as same as possible. We cannot go beyond 32-bit instruction. We have to use the same 32-bit instruction, 32 bits, and encode the new instruction format. What will be your first step, like looking at this format? So first of all, we have RD, which is x19. In this format of instruction LW, we have RD, so we can keep it intact. We do not need to change this. Similarly, we have source register 1, RS1. So we do not need to change it. We do not have RS2 in this format. Can we use RS2 to encode this value? Why?
It's not big enough.
It's not big enough. Do you get that? Can we encode this value 52 in RS2? Can we use the RS2 field? Because in this instruction format, we do not have second source register. So when we do not have a second source register, we can use that space, RS2 space, to store this value, offset value. Can we do that? The answer is no. Why? Because it is not big enough. What do I mean by that when it is not big enough? Yep.
There's not enough bits to represent
52. So which means that we can only represent, up to what maximum value we can represent? 31. Because in 5 bits we can represent a positive 31 value and the negative maximum minus 32. Okay? So it is not enough, and we have already been talking about this offset value is always a 12 bits value, and the reason why it is 12 bit because they have already designed this. So the format is we can merge these two fields together, okay, RS2 and func7, to come up with a new instruction format while keeping the size of the instruction same. So this is called I format. So I format, whenever I use term I format, you always remember this I corresponds to immediate, which means that it has an immediate data. Either it could be a data or it could be an offset value, like an LW instruction. It could be add I instruction as well. Okay? So in the immediate format, these two fields, RS2 and func7 field, are merged together to form a 12 bits immediate data. It's always a 2 complement value, and it is sign extended. Sign extended means whenever an immediate value is specified and we need to perform some operation, let's say, let me give you an example here. So for example, if I have instruction like this, add I, x9, x10, and let's say 12. Okay, now this 12 is actually represented in 12 bits. Sorry. Okay, so these are 12 bits. It has to be added into x10. What is the size of x10? X10 is 32 bits, right? So whatever the value of x10, let's say it is something, let's say 2. Okay, so it is 32 bits wide. So this immediate value is first extended into 32 bits and then added into the other operand. Okay, always it happens like that, whether it's an data or even if it is an offset. Offset means like the memory offset. It is always first extended. Now if the sign is 0 here in this 12-bit value, the 0 will be extended and replicated to upper 20 bits. If it is 1 here, This is sign extended, means all the ones are replicated here. We have discussed this couple of times before. Okay, so it was just a reminder. Okay, so since only 12 bits are kept in machine code, we can represent the immediate value that can be represented with minus 2 to the power 11 plus this value, which is equivalent to minus 2048 to 2047. Okay, so let's say we have this instruction, and this is how we encode this. So add I, so this is the immediate opcode value, which is equivalent to, what is the equivalent value here for this one? This one is not 51. 1, 2, 4, 8, 16. 16 plus 3, 19. And then we have the x1, which is the destination register, and then the source register 1, which is here, RS1, and 32 is placed here. Okay, and I have already mentioned this, when executing the instruction, it is extended into 32-bit first and then added into the contents of x2. Okay, so this is the I instruction format summary. You can see add I, SLLI, SLTI, and all I instructions have the same opcode. Okay.